Hello and welcome to the YouTube channel D Creations Resources. These days we're talking about different aspects of spectroscopy. Today let us talk about UV visible absorbance spectroscopy and its use for the determination of optical band gap of a semiconductor, like for example zinc oxide. Now this determination is done from a Tauc plot. So what is a Tauc plot? A Tauc plot is a graphical method for determination of the optical band gap of a material and is based on the relationship between the absorption coefficient alpha and the photon energy h-nu of light. Now typically there is a graph made where on y-axis you have alpha h-nu raised to n and on x-axis you have h-nu. So alpha h-nu raised to n versus h-nu. So when I am saying alpha h-nu raised to n, I mean to say alpha h-nu combined in a bracket and that whole bracket raised to n. Now here alpha is the absorption coefficient, h is the Planck's constant whose value is 6.63 into 10 raised to minus 34 joule second. Nu is the frequency in hertz and n depends on the nature of the transmission. For example, for a direct bandgap material it is equal to 2, while for an indirect bandgap material it is equal to half. Now the basic equation is alpha h nu raised to n is equal to k into h nu minus Eg. So h nu minus Eg in a combined bracket of course, and k, instead of k sometimes some other letters like a etc are also used. Now by plotting alpha h nu raised to n versus h nu, from this graph we are going to identify a linear region and then it is going to be extrapolated, this linear portion is going to be extrapolated to the horizontal axis, which here is the energy axis, because on x-axis we have plotted h nu on the horizontal axis. So we are extrapolating the linear portion to the energy axis. So when I say I'm basically wherever it cuts the energy axis or the horizontal axis, at that place the y coordinate will be 0. That means alpha h nu raised to n is going to be 0. And the basic equation, the Tauc relation, Tauc and Davis-Mott relation, says that alpha h nu whole bracket raised to n is equal to k into h nu minus Eg. Now please remember, instead of k, as I said, any other letter can also be used. So when you are saying in the graph alpha h nu raised to n is 0, the y coordinate is 0, that means h nu minus Eg is essentially equal to 0. So h nu is equal to Eg. That is the logic. Now optical band gap is a very important parameter depending on which the precise application of a semiconductor material can be decided. So it's very important to know the proper band gap value of it. And Tauc with his co-workers developed this semi-empirical method. Now you must be aware that the optical band gap, or sometimes also called the optical gap, is the minimum energy that a photon must have to be absorbed by a material, causing an electron to jump from the valence band to the conduction band. Now coming back to zinc oxide, it is a wide band gap semiconductor, and that means it has a relatively large energy difference between its valence band and conduction band. When I am saying relatively, you can compare it with semiconductors like silicon or germanium. So for germanium it's just 0.7 eV, or for silicon it's around 1.1 eV, but here it is 3.3 eV. ZnO has several applications, and the most important one here we would mention is the application for solar cells, and that is of course due to the properties that it shows. It even has applications in biomedicine or in cosmetics like sunscreens, etc. But here of course we are talking about the prime application that is related to a semiconductor. Thank you.